DFA, NFA and epsilon NFA. So in DFA, we won't get epsilon transitions. That is one point. And in NFA, we may come across one particular state in which it tries to transit on the same input to different states. But in DFA, we do not have that ambiguity. On a particular input, the transition will be clear. For example, if I write Q0 on A, Q1, on B, Q2. So this is DFA. Suppose if instead of this B, if I write one more A, wherein it says Q0 to Q1 on A as well as Q0 to Q2 on A, this becomes NFA. And suppose if I replace this A by epsilon and let this A be like this only, this becomes epsilon NFA. So this is the basic difference between epsilon NFA, NFA and DFA. Now let us try to understand how we can convert this epsilon NFA into its DFA form. Okay, now to begin with, we will have to construct first the transition table. Now transition table will be built like this. This is the delta. Okay, then input symbol A, B, and we do have epsilon as well as. And what are the states? Q0, Q1, Q2. Since Q0 is initial state always will be prefixed by arrow, and final state will be indicated using double circle. So this is final state. Here I will mention it as final state. Now let us build the transition table. Q0 on A, it will be in Q0 only. Q0 on B, there is no transition from Q0 to any state on B, so I will write null. Then Q0 on epsilon, it goes to Q1. Then Q1 on A goes to Q2. Q1 on B will be there itself. Then Q1 on epsilon, there is no transition. Now coming to the last state, Q2 on A stays on the same state. Q2 on B also on the same state. Q2 on epsilon, there is null transition. So this is our transition table. Next we need to find out epsilon closure of each state. Now that means we can write like this: epsilon closure of Q0 is. Now what is this epsilon closure? Now on epsilon, if it takes a transition from some state to some state, we are supposed to write it over here. Now by default, epsilon closure of any state is that state itself union by other states. Now see here Q0 itself, we have to take this for any given state. Then Q0 on epsilon has transitioned to Q1. So union it. We got Q1, Q0, Q1. Then we don't have other transitions. End it here. Similarly, epsilon closure of Q1, that is Q1 itself. Any epsilon transitions are there? No. So it is only Q1. Then epsilon closure of Q2, Q2 itself. Then any epsilon transitions are there with respect to Q2? No. So that is epsilon closure of Q2. So we got epsilon closure of Q0, Q1, Q2. Now we have to build the exact DFA table for this given NFA. Okay, now that we have epsilon closure of all the states, now let us take one by one. Once again we need to build the transition table for DFA. Okay, it will be delta. And this time we will be taking only A and B input symbols. A and B input symbols, because we are constructing DFA, so we have to avoid epsilon transitions. Now first state you take, that is Q0, Q1. We need not take this state. We have found the epsilon closure of this state. So epsilon closure we are supposed to take, that is Q0, Q1. Q0, Q1. Q0, Q1 on A, we have to find out. And this you can obtain from the transition table which we built previously. Now Q0, Q1 on A, Q0 on A, Q0, Q1 on A, Q2. Then, now Q0 on Q1 is Q0 on A will be Q0. Okay. Then Q1 on A will be Q2. Now what is the epsilon closure of Q0? It is Q0 Q1. What is the epsilon closure of Q2? Q2. So union these two and write it over here. That is Q0 Q1 Q2. I hope you understood. Now similarly find out for Q0 on B and Q1 on B. So Q0 on B is null. Q1 on B is Q1 itself. So Q1 union null is Q1. So what is the epsilon closure of Q1? It is Q1. So it is Q1. Similarly, now we are done with this. We have a new state here. Okay, that is Q0, Q1, Q2. Find out Q0, Q1, Q2 on A. Already we know Q0 on A is Q0, Q1 on A is Q2, and Q2 on A is Q2 itself. So we get union of all these states. So Q0, Q1, Q2 on A is Q0, Q1, Q2 itself. Now Q0, Q1, Q2 on B. So Q0 on B is null. Already we have found out. Q1 on B is Q1. Q2 on B is Q2. So Q2 on B is Q2. Its epsilon closure is Q0. So union these two, you get Q1, Q2, right? Q1. So we are done with this state. Now we have another new state, that is Q1. Just find out Q1 on A is Q2. Epsilon closure of Q2 is Q2. Q1 on B is Q1 itself, and epsilon closure of that is Q1. So we are done with this state. Now we have Q1, Q2. Q1, Q2. Now once again find out Q1 on A and Q2 on A. Q1 on A is Q2 and Q2 on A is Q2. Okay, so we get Q2. Q1 on B is Q1. Q2 on B is Q2. So Q1, Q2 union. We are done with that. Next, we have only one new state, that is Q2. Bring it over here, Q2. Now Q2 on A is Q2 itself. Its epsilon closure is also Q2. Q2 on B is once again Q2. Its epsilon closure is Q2 itself. Now that we are done with transition table for constructing or putting DFA, this table helps us in putting the DFA corresponding to this epsilon NFA. Okay, now that we have the transition table for DFA, now we have 5 different states. 5. So that we have to represent, or we have to show how to construct DFA for the given transition table. Now we have Q0, Q1, one state. Then Q0, Q1, Q2, another state. Okay. Q1, another state. Q1, Q2, another state. And we have Q2. So in the given epsilon NFA, Q2 is final state. So we are supposed to make wherever we have Q2 that as final state. And Q0 is the initial state. And we know that for a given automata, one initial state will be there and several final states may be there. So now Q0, Q1 on A goes to Q0, Q1, QA, Q2. Then Q0, Q1 on B goes to Q1. Then Q0, Q1, Q2 on A remains in the same state. Q0, Q1, Q2 on B goes to Q1, Q2. Then Q1 on A goes to Q2. Then Q1 on B remains in the same state. Then Q1, Q2 on A moves to Q2. Then Q1, Q2 on B remains in the same state. Then Q2 on A remains in the same state, as well as for B it remains in the same state. So this is the DFA we got for the given problem. I hope you understood this conversion procedure. Thank you.